everyone, and welcome to the first of the Reality of Net Zero seminar series. A warm welcome from myself and from Professor Miles Allen. We're excited to share more about our work and have a productive discussion today about the net in net zero. So this Reality of Net Zero series explores why we need net zero, the progress that we've made and not made on it so far, and how we can achieve it in a way that is fair. This is a collaboration between Oxford Net Zero, the Zero Institute, and OxEarth, and it lasts for 8 weeks. You can find the schedule and all of the topics on our website, netzeroclimate.org. During the session, you'll be able to ask questions. You can do that using the Q&A function, and if you see a question that you like or agree with, then you can upvote it by using the thumbs up emoji. So the way that we'll structure it is that I'll present first, then Miles, then we'll have time for questions and answers. So with that, we'll jump straight in. So my name is Alexis McGivern. I'm the head of stakeholder engagement here at Oxford Net Zero, and delighted to be with you today to talk about net zero at an organizational level. So before we start, I always like to start presentations with this message from Catherine Wilkinson, who put together this anthology about not only all that we've lost with climate change, but all that we can save if we act quickly and swiftly and in line with the level of ambition required to meet the moment. So while there's lots of terrifying climate news, it's an amazing time to be alive, where every action that we make really has a marked difference on our future. So what we'll cover today, a brief one on what is the net in net zero, brief because our colleague Dr. Steve Smith will be covering this in a later webinar. What are the concerns with the net in net zero, and what is the guidance given to individual entities as to how to use the net in net zero? So we've got a poll question of whether or not the net in net zero is helpful or a distraction. So I see those answers coming through. It looks like we're leaning towards the net in net zero being helpful. So that's good to see. We'll keep that open for another few minutes. And just while we wait for that to come in, just thought I'd mention, Miles actually taught me as a graduate student in 2019. And so if anything today is wrong in this presentation, it's Miles's fault. But it's a really great opportunity to be here, to be able to have a productive and collaborative chat with a colleague, former teacher. So great. So we now see that we're leaning towards the helpful. I'll actually end that poll there to get stuck into the net in net zero. So just before we get into that, just a reminder that these are some kind of incontrovertible truths about climate change. We know that it's happening because of human activity. We know that those who are least responsible and most vulnerable will bear the largest impacts. And we also know that we're at a critical intervention point that will allow us and other living creatures to face a livable future. But also how we govern those interventions really matters. So this is a graph from Our World in Data. And as you can see, we have different trajectories that lie before us. And I think the scariest one is that red one at the top, which is the potential emissions in a no climate policies, no collaboration scenario. We see we can get up to nearly 5 degrees of warming with no collaboration. And then we see the orange strip. And while that is far above where we want to be, we obviously want to keep warming to below 1.5 degrees. And with our current set of policies, we're looking towards sort of a 2.5 or actually up to 3.1 degrees of warming. And I know that is terrifying, especially when it comes to the distance between that and a 1.5 degree pathway. But I'd just like to ground us in the fact that the decisions that we make do have a material difference on how much warming we end up with. And so our work is really around the governance of net zero and making sure that actually happens. So what is net zero? Good question. We look at net zero at the global scale, and lucky to be sitting next to Professor Miles Allen, who is the scientist behind net zero, and you'll hear more from him in just a second. But it's really about achieving a balance between greenhouse gas emissions and those taken out of the atmosphere. And this is language directly from the Paris Agreement, which is the international treaty that governs international climate policy. But it's translated from a scientific principle into the Paris Agreement. It's about reaching a global peak of greenhouse gas emissions as soon as possible, with the recognition that this will take longer for developing country parties, with the goal to reach a balance between emissions of sources and sinks, emissions by sources and removals by sinks in the second half of this century, so by 2050 at the latest. And so our work at the Oxford Net Zero research group really involves translating this global goal into what guidance would be for individual corporate actors or other non-state actors. We have plenty of colleagues working on state level action, as you'll hear from Dr. Lavanya Rajamani, who will be speaking about nationally determined contributions and national climate policy. But for today, we're just going to focus on non-state actors. And so what we work on is ensuring that non-state actors are decarbonizing in line with the following principles: meeting the urgency of meeting the zero, having integrity over the net, as that is the carbon removals part of net zero, and doing so in a way that is consistent with sustainable development objectives. So that demand of making sure that non-state actors are decarbonizing in line with those principles, that means we need rules. We need rules about how non-state actors are behaving and setting and implementing their net zero strategies. Or if we're being academics about it, we need an ambitious governance system for net zero. So what we look at in our team is what guidance is given to individual entities on how to reach net zero. And specifically, what we're interested in today is how are they considering the net in net zero? So we look across the governance landscape, across the more than 30 standards that govern how individual entities set targets, measure and report emissions, use offsets, and set interim targets. But today we're going to look at how can or do removals fit into the picture of translating the global goal of net zero into guidance for corporates specifically, but other non-state actors. So the net in net zero refers to the cautious use of carbon dioxide removal. And again, we have an upcoming seminar from our colleague, Dr. Steve Smith, on February 19th. But just a few things to note that will help contextualize our conversation today is we have not been reducing emissions at the rate we ought to over the last 50 years or so. And that the IPCC, the Intergovernmental Panel on Climate Change, highlighted that carbon dioxide removal will be required to limit warming to 1.5 degrees, as we saw earlier, is enshrined in the Paris Agreement. And this will be especially important to counterbalance the emissions from the difficult to decarbonize sectors, so things like agriculture or long distance transportation. So then the question becomes, how do we use carbon dioxide removal in a way that is both safe and responsible, and also does not take our foot off the pedal when it comes to our urgent and much needed mitigation goals? And so what are the concerns with the net in net zero? These are a handful of headlines from some journalists, some think tanks, as well as civil society, speaking largely about one form of carbon dioxide removal, which is carbon capture and storage. But there's a lot of concern that the net in net zero is holding back our urgent mitigation goals. So let's walk through some of the concerns. So the net itself, the actual localized impact of carbon removals, this, and especially as regards to things like carbon capture and storage, these are largely being located in communities that have also experienced issues with oil and gas impacting health and day-to-day life. So this is, for example, the case in Louisiana, also known as some areas known as Cancer Alley, where the petrochemical industry has been operating for decades. And now there's a concern from activists that they're shifting from the petrochemicals industry to the carbon capture and storage industry. The dangerous delay, so the reliance on future mitigation potential rather than cuts now. And this is from a paper that is actually nearly a decade old that basically summarizes it quite well, is the promise of a future and cost-optimal negative emission technologies is more politically appealing than developing policies to deliver rapid and deep mitigation now. So that's the other part of the concern, is that relying on future mitigation potential rather than cutting now. legitimizing continued fossil fuel use, especially when it comes to carbon capture and storage, which is one type of carbon removal, as I mentioned. And this is from some research that basically showed that nearly 75% of carbon capture and storage at the moment is being used for enhanced oil recovery. So carbon dioxide, carbon capture and storage being used to push more oil and gas out of the ground. And that has big red flags for activists and campaigners. And then finally, costs and trade-offs, specifically as with regards to energy use or land when it comes to bioenergy, carbon capture and storage, as well as the financial costs. But so the question then becomes, so what guidance is given to individual entities on how to approach the net in net zero? So here are the three questions that we'll go over. Are there any references to removals when it comes to the standards that govern corporate climate action? How are removals considered as part of a legitimate or high integrity net zero strategy? Is there any specific guidance on how to prepare for the use of removals? And what, if any, are the conditions on the use of removals? So starting first with any references to removals. So these insights come from our mapping report, which I mentioned earlier, where we went through the 37 different standards that govern non-state actor action on climate and coded them along 64 different criteria to see what they were saying. And this is from our removals section of that report. So there's widespread acceptance that removals and offsets should only be used for hard to mitigate sectors at the net zero target dates. That there's also widespread acceptance that emission reductions and removals should be counted in two separate ledgers, so they shouldn't be conflated, and that they should not be used to meet interim goals, so that the reduction and mitigation should be the priority. However, we do see in the standards quite a conflation of the words around removals and around offsets in net zero standards. And sometimes some standards have a specific stipulation over using CCS over any other type of carbon dioxide removal, which from the context of the presentation so far, you can see how that's flawed and limited. Then a question around investment in removals. This is some direct text from 3 standards that have direct language on investment in removals. So from the International Standards Organization, from their net zero guidelines, which are now being developed into a full auditable standard over the next few years. Their language is around invest early in high quality, long-term removals if you anticipate needing to rely on that by the net zero target date. CDP also says report on your near-term investment for neutralization at the target year, and Transform to Net Zero, which is a coalition of ambitious businesses. They say that members should create net zero aligned carbon removal plans with time-bound KPIs. So this is some of the good. Whereas others, and actually many, make no specific reference to removals. They only say they should use high quality carbon credits without actually stipulating what makes a carbon credit high quality. And then lastly, asking about if there are any conditions on removals. So in the standards, when we're speaking about offsets, then additionality becomes key. So whether or not that activity would have happened without the incentive of a carbon credit. But in many standards, there's specific reference to permanence or durability as a key condition of removals, although there's different language on this. So some say permanent, just the word permanent without really a definition of what that means. Some say on a centuries or a millennium timeline. And most guidance say that only between 5 to 10% of emissions can be counterbalanced through removals. However, we do see a conflation of removals and offsets for use at the net zero target date, and there's quite a bit of mixed guidance on permanence, especially where natural climate solutions are specifically listed as the carbon removal technique. So in summary, we are worried about the net in case it impedes or causes any further dangerous delay to pursuit of the zero. But existing delay to date requires removals. And so what we need is cautious carbon dioxide removal with strong guardrails on permanence, scalability, safety, verifiability, and acceptability to the public. What's most important is that we need to ensure that the net zero governance landscape, especially for corporates, is really strongly airtight and doesn't have any sort of encouragement on lagging on near-term mitigation goals, while also incentivizing creating an investment plan for removals if we feel they might be needed at the net zero target date. So with that, I'll hand over to my colleague, Professor Miles Allen. That's my email if you have any further questions. And over to you, Miles.
Thank you. Well, thank you, Alexis. And Alexis has given us a great introduction to the overall challenge, particularly for non-state actors in thinking about net zero. I'm going to be talking to you a bit more about the basic science behind it, and where the call for net zero comes from. As Alexis already said, it sort of originated in the Paris Agreement back in 2015, although the science behind the Paris Agreement was largely done in the late 2000s, culminating in a whole series of papers being published in 2009, and then picked up in the IPCC's assessments, in the fifth assessment report in particular of the IPCC in 2013-14. So to remind you of the wording of Article 4, the crucial net zero phrase is to achieve a balance between anthropogenic emissions and removals by sinks of greenhouse gases, anthropogenic emissions by sources and removals by sinks of greenhouse gases in the second half of this century. And you might think straight off, well, that's crystal clear, very obvious what everybody means. And I'll try and explain to you how actually there is a little bit, or to be honest, it's a little bit controversial whether or not it's even controversial. So there is scope for some controversy about exactly how Article 4 can be interpreted. Important to stress, we in Oxford Net Zero look at these questions, but of course it's only the parties to the Paris Agreement that have any authority to interpret it. All we can do is talk about how people are interpreting it and what the implications are of different interpretations. So the background to this and sort of the interpretation I think that most people use is the net zero emissions as defined in the IPCC assessment reports, such as the IPCC fifth assessment, which informed the Paris Agreement, is what it takes to stop carbon dioxide from causing global warming. One thing Alexis didn't mention, although you did very well keeping to time, so there's other greenhouse gases involved, of course, and methane in particular is a big driver of global warming after carbon dioxide at the moment. And we're really focused on carbon dioxide here. Make no apology for that, because that's the biggest driver. And without stopping carbon dioxide from causing global warming, we can't stop global warming. We just have to remember we also have to do some other things as well. So don't forget that methane is important, but we're focusing on CO2 here. So to stop CO2, carbon dioxide causing global warming, we need to reduce the emissions by under the IPCC's definition, which means active. So emissions from fossil sources and active deforestation, land management. We need to reduce that to zero. That's the big black line on the left. And what happens when we do that is the concentration of carbon dioxide in the atmosphere, the blue curve in the middle, goes up and then starts coming down again. And that means that the reason for that is that Mother Nature, the combination of the terrestrial biosphere and the oceans, continue to absorb carbon, what we call passive uptake, because it doesn't require any active human intervention for that to happen. And that draws down CO2 concentrations in the atmosphere, and that's what it takes to stabilize global temperatures. I did say it doesn't require any active human intervention for that to happen, in the sense that if humanity were to somehow cease to exist or cease to do anything after mid-century, this is how the carbon cycle would evolve. That said, we are counting on the natural carbon cycle doing that. And as long as humans are still around doing stuff, and of course we very much hope they will be, then the biosphere will need protection. Mother Nature will need to protect it from ourselves, so to speak. And so that may need quite active protection measures. So I don't want to imply to you that this is something very easy that we can totally count on Mother Nature doing. We still have a responsibility to make sure that she can. So that's what that's why net zero works, in the sense that if we stop dumping carbon dioxide into the atmosphere, then Mother Nature helps out by drawing down CO2 concentrations in the atmosphere, and that's what it takes to stabilize global temperatures. And in the late 2000s, this was a relatively sort of fairly radical science, if you like, because up until then, everybody only ever talked about stabilizing CO2 concentrations in the atmosphere, which would mean making that blue line flat rather than falling. The challenge we got, so this is what it takes to stabilize global temperature. That all came out in 2009. And if you're interested, the authors of those six papers, there were six papers all published in quite quick succession in 2009 that established this science. And the authors of those papers have got together to publish another a review article just recently, and it's already accessible in accelerated article preview, looking at what was meant by net zero in those papers and introducing in particular the phrase geological net zero, which if you go back and look at what the scientific papers said back in 2009, this is what was meant, what we understood was needed to halt global warming. By the way, as a matter of history, if you go back to those papers, you don't find the phrase net zero. There is sort of one mention of zero net emissions where it's clear that what's intended is a balance between both fossil emissions and active removal to geological storage. The emphasis on net and the phrase net zero really popped up in the IPCC synthesis report in 2014. And that's, I think, sort of perhaps one of the reasons why there's so much controversy around it is because people are anxious that the net in net zero was kind of inserted to make it a bit easier and potentially less effective because there is unfortunately a potential ambiguity. And I say potential ambiguity because I say it's even controversial whether it's controversial. There's a potential ambiguity in what we mean by removals by sinks in the Paris Agreement. If, for example, we were to consider all of that uptake that Mother Nature is doing for us, the absorption by the land and by the oceans, if we were to claim that as a removal by sink, if we were to claim in particular that it was anthropogenic, which most people would agree is certainly for all of it would not be the correct interpretation of the Paris text, but it's sort of sufficiently flexible, shall we say, that some people might like to push the definition in that direction, then we would find that nominal emissions today would be much lower than they are because half the CO2 we dump in the atmosphere, only half the CO2 we dump in the atmosphere at the moment remains there. The rest is absorbed by the oceans and the land biosphere. But we would also, so that sounds like a good thing. Of course, it's not a thing at all, really. It's just a reclassification of something that's happening anyway. But we would then find that our nominal emissions would actually have to fall well below zero to about minus 10 billion tons of carbon dioxide per year in order to actually halt the warming. So it really matters what we include in this removals by sinks in the definition of Paris balance. Because if we don't account for this, if we just aim for net zero emissions, but assuming all of this passive uptake is counted as a negative emission, and people take credit for it and use it to offset their ongoing fossil fuel emissions, then achieving net zero would only stabilize CO2 concentrations. This is, so here you see CO2 concentrations stabilizing. You could say the old sort of Rio target, if you like, stabilization of greenhouse gas concentrations in the atmosphere, but that allows warming to continue. And if we were to stabilize CO2 concentrations at around 1.5 degrees, we would actually find the world would warm by a further half a degree over the following century. So that doesn't deliver the goal of the Paris Agreement. It helps, of course. I mean, it slows down the warming, but it doesn't actually stop it. Only if we include only active removals, and crucially, active removals that don't displace passive uptake, only these can be included in the definition of net zero if net zero is actually to halt warming. This issue of displacing passive uptake, if you're counting on a forest, for example, to absorb carbon from the atmosphere, you can't use that same land for a bioenergy with carbon capture and storage facility to grow trees, which you're claiming as a negative emission, if you've thereby wiped out the capacity of that patch of land to absorb carbon passively from the atmosphere. So you see the tension here. We've only got one Earth available, and so if the particularly carbon dioxide removal options that involve pressure on land run the risk of displacing land that we need to actually just do its job and absorb carbon that as a result of our past emissions. So moving on from the physical requirement of what it takes to happen to emissions and so on, what happens in scenarios that actually succeed in the Paris Agreement goals, limiting warming to well below 2 degrees and close to 1.5 degrees? And this is where this sort of illustrates the importance of the net in net zero, certainly in these more ambitious climate scenarios. Back in 2009, if we'd started reducing the amount of carbon dioxide we produce from burning fossil fuels immediately, if we just started then to reduce our use of fossil fuels, and if the goal was still 2 degrees, which of course that was what the goal was back in 2009 in the time of the Copenhagen Agreement, then it's probable that we would have been able to meet that goal without relying on disposing, by just simply reducing the amount of carbon dioxide we produce. But unfortunately, as you can see from the beginning of these lines, actually emissions just carried on going up. They didn't start going down in 2009. And also we've increased the ambition of climate policy. We're aiming to limit warming closer to 1.5 degrees. So we need to augment our efforts to reduce the amount of carbon dioxide we produce, which is shown here by the red line on this graph, by increasing the amount of carbon dioxide we dispose of permanently, capture and store back underground. That's the blue line, which you can see represents capturing of CO2. So just to sort of make this clear, we need to burn less by replacing fossil fuel applications with others like wind and solar, non-fossil alternatives, and we need to store more. We need to increase the amount of carbon dioxide we capture and dispose of back underground. That's the blue line here. This graph here is ambivalent. It's ambiguous on how much of that blue line is actually captured at source, what people refer to as CCS, or how much is recaptured from the atmosphere. And I would argue that the more that's captured before it goes into the atmosphere, the better, because recapturing carbon dioxide from the atmosphere is actively removing carbon dioxide from the atmosphere takes a lot of energy, and it's still pretty nascent technology. So the more we avoid dumping into the atmosphere in the first place, the better. There's also a very important contribution shown by the green line from reducing deforestation and enhancing carbon dioxide storage, carbon storage into the biosphere through nature-based solutions. You can see the green line goes from plus 4 or so billion tons of carbon per year at the moment, which is the amount we're putting into the atmosphere due to deforestation. We've got to stop that as soon as possible. Many countries are aiming to stop deforestation around 2030, and some are making good progress towards that, and reverse it. So we need to start restoring carbon to the biosphere. But you will notice that one thing is that quantifying this, the green line here, quantifying the transition from deforestation to nature-based solutions is challenging because it's happening in the context of all of that passive CO2 uptake by the oceans and biosphere that results from past emissions. And of course, as we've seen, recently with the wildfires in California, which have caused such hardship there, there is a risk as the world warms that carbon we store at the Earth's surface may end up going back into the atmosphere anyway. So I tend to, I mean, Alexis and I, you probably picked up that Alexis and I, there's a certain tension, and it's an academic collaboration here, and we just, we argue quite a bit about the role of geological carbon dioxide disposal, of sort of engineered disposal of carbon dioxide, because and I totally buy the concern that there is a worry that people might say, oh look, sure, we can engineer our way out of this. Let's not worry too much about reducing emissions. We can just capture the CO2 and stick it back underground, and everything will be fine. So I totally appreciate people's concerns with that sort of over easy sounding solution. But the obverse of that is, if we don't do this, we're in trouble, because if you look at the total amount of carbon dioxide we avoid dumping into the atmosphere by 2100, and what it is, where that carbon dioxide goes, or where it doesn't come from, um, about 2 to 3 trillion tons of carbon dioxide represent what we avoid producing by replacing fossil fuels, and replacing fossil fuels with non-fossil energy sources and so on. So that's, everybody's very familiar with that. Everybody's familiar, and many countries, many companies are really trying hard to reduce the amount of carbon dioxide they produce. But a further trillion tons, so not the same amount, but still a big chunk, is captured and stored back underground by 2100 in these scenarios that meet the goals of the Paris Climate Agreement. And that's so it's sort of 30% of the solution, and it's receiving only a tiny fraction of investment in the transition. If I just highlight here, this is just numbers from Bloomberg New Energy Finance, but if I just highlight here what people are investing in that's relevant to reducing the amount of carbon dioxide we produce, it's the vast bulk, and only two little lines there in the middle, hydrogen and carbon capture and storage, are directly relevant to increasing the amount of carbon dioxide we store. So I would totally agree with Alexis, and indeed everybody, that the absolute priority has to be reducing the amount of carbon dioxide we produce. It's far better to avoid producing carbon dioxide in the first place than it is to worry about how you dispose of it. But we are going to produce too much. If that might not have been true back in 2009, it's certainly true today. So we have to work out how to scale up permanent, safe disposal of carbon dioxide in order to meet our climate goals. To put it simply, we need to stop fossil fuels from causing global warming before the world stops using fossil fuels, because there are applications of fossil fuels, such as aviation, for example, where we won't have an alternative available in time to meet our climate goals, and therefore we need to scale up permanent carbon dioxide, permanent disposal of the carbon dioxide they generate. I mentioned aviation, of course, because that's a particularly challenging one, because that's an activity where you have to release the carbon dioxide into the atmosphere, and therefore you've got no option but to recover it and take it back out again. We must produce less CO2, and it's not an either or, and dispose of the CO2 we still produce by the date of net zero. We're going to get on to policies and so on behind this, but I just want to sort of flag to you that carbon pricing mechanisms, such as emission trading systems, are not delivering this carbon dioxide disposal at scale at the moment. It's receiving only a tiny amount of investment, because investors are quite sensibly simply looking at what it costs to reduce emissions at the moment, and carbon dioxide disposal is relatively expensive. One of the things that I've advocated for over many years is something like a carbon dioxide disposal obligation, which would require people who are bringing fossil carbon into the world economy to get rid of it, getting rid of a progressively increasing fraction of the carbon dioxide they introduce, as a way of ensuring that we actually have, creating a backstop policy, if you like, to ensure that we achieve net zero, no matter what else happens, to all of the other measures we're taking to reduce the amount of fossil fuels we use. And you can read more about that idea on carbonbalance.earth if you're interested. But I'm sure there'll be plenty of questions from this, so I'm going to well, as well as reminding you, but don't go away. No, don't join us next week. Should we go back to the opening slide, or
stop sharing actually, and
just stop sharing? Yeah, that's right. That's probably the better way of doing it. Hopefully I can see out of the corner of my eye plenty of questions coming through, so I'm sure we've got lots of questions to address now.
Great, thanks so much, Miles. So I guess to start, and this is just an important one to clarify. This is a question Do you mean the Paris Agreement and IPCC definition of net zero are inaccurate and too
No,
inflammatory?
no, absolutely not. I never suggested they were inaccurate. There is some, I would argue there is some ambiguity in what is included in removals by sinks in the Paris Agreement. The IPCC is, I would argue, less not ambiguous at all about this. The only activities that are included in removals by sinks by the IPCC definition, which you can look up in the IPCC glossary, are active human interventions and well, one thing which is missing there, but I think it's kind of implied, active human interventions that don't compromise natural carbon dioxide uptake in any way. So the only things that the IPCC includes in removals is the processes like literally capturing CO2 out of the atmosphere, compressing it, and injecting it back underground. That would count unambiguously as a removal under the IPCC's definition. It would also count as a removal under the Paris definition. But the ambiguity in the Paris language is, for example, if a forest is growing faster naturally just because there's more carbon dioxide in the atmosphere, well, you could argue whether that's entirely natural because the carbon dioxide is in the atmosphere not naturally in the first place, then it is that sort of enhanced forest growth, can that be counted as an anthropogenic removal? And that's where there's a little bit of ambiguity in the carbon accounting systems we have. And it matters because the numbers are large. And we are counting on Mother Nature providing us this service to remove carbon dioxide. And we're counting on her continuing to provide this service to remove carbon dioxide for the indefinite future. And we need to look after it and not take credit for it and pretend that this was something we achieved ourselves.
Thanks, Miles. The next question, which I think is for me, is a view on organizations' use of high quality credits for interim targets on the path to net zero. Um, so I guess just to be clear, the way that the net zero governance landscape defines the use of credits is that credits should be counted separately from emissions reductions. And this is key in order to make sure that we're not using credits to justify an increase in emissions. So for example, if I'm a company based in the US and I want to purchase credits that will allow me to justify to continue to emit, that just the math doesn't work at a global net zero level. And that's part of the issues in mistranslating the global goal of net zero into organizational level criteria, because what we're hoping is that these standards encourage alignment with global net zero rather than everyone trying to net their own emissions simply through the purchase of credits. In general, the use of credits towards interim targets is discouraged for that specific purpose of trying to encourage near-term mitigation goals. And increasingly, there's guidance that credits should be used and recognized in their contribution towards beyond value chain mitigation. So recognizing the impact and the investment that you've made through, as we say, an additional, mitigation that has been caused by the purchase of a carbon credit that otherwise might not exist. But instead of using that to legitimize new emissions on your side, instead showing it as on a different ledger, a contribution to global net zero. So just making sure that we're not trying to net emissions at your level, but demonstrating a contribution to global net zero.
And if I just chip in on
Yeah.
that, I was referring to this recent review paper, the one, it was a really interesting exercise gathering together all the authors of those 2009 papers and really thrashing out what everybody meant. But one thing everybody was absolutely clear on was the need for separate accounting for emissions and removals so that we know what's going on and we know whether or not everybody's counting on the same removal to offset their emissions, because at the moment it's not clear where we're going, and so just that additional transparency is all important at the moment.
Great. Here's another one for you, Miles. To what extent does the 30% figure for geological disposal depend on economic and political assumptions, i.e., infeasibility of deeper and more rapid reductions?
Yeah, I mean, this is what comes out of the IPCC's so-called cost-effective scenario. So this is sort of the if you do all and only the measures that are the most cost-effective way of achieving net zero, then that's what emerges. And obviously, you sure there's a big uh, blue shaded bar of uncertainty in that. And there's obviously, we're speculating about how technology costs are going to evolve over the next 50 years. So, you should be careful with anybody's prediction on this. So am I confident it's going to be 30%? No, of course not. Am I confident it's a lot? Yes. And am I confident it's a lot more than we are investing in that part of the problem at the moment? Absolutely. So this is not a 1% contribution. Whether it's to be honest, I could even say whether it's a 10% or a 30% contribution, well, that means we need to scale up geological CO2 disposal by either a factor of 10 or a factor of 30. I mean, scale up our investment in it. And the actual activity, we need to scale up by factors of 100. So, we can lose a lot of sleep, I think, at the moment, worrying about how big that chunk has to be, and distract ourselves from realizing it's whatever happens, it's going to have to be enormous compared to what we're actually doing at the moment. So that's the main message to get across to people. Right now, we dispose permanently of less than 1%, actually less than 0.5% of no about, sorry, I'm doing maths in my head, which is always a mistake in a seminar, of around 0.1%, so 1,000th of the carbon dioxide we generate from burning fossil fuels. And to stop fossil fuels from causing global warming, we need to increase that to 100% because we need to get rid of it all. So that sort of puts the challenge into perspective.
Great. Thanks so much, Miles. Another question is 1.5 degrees a reasonable goal considering 2024 saw us reach the breach of 1.5 for a year? I'll win and then I'll pass over to you, Miles. I think so 1.5 degrees is almost both a scientific limit that we understand through experts, as well as a political goal that was hotly negotiated between developed and developing parties during the Paris Agreement. And during that time, a lot of, especially small island developing states, had the rallying cry of 1.5 to stay alive. And so that being basically the difference between them keeping their nation states and not. And so while we know that the science behind 1.5 being the point at which it will be harder to control and come back from irreversible climate change. It is also, I think, an important political North Star to keep on the agenda at COP28 rather. There was a moment where some of the text dropped reference to 1.5 and just had a 2-degree reference. And it was very stressful and difficult, as you can imagine, because whether or not we will breach 1.5, which given our level of delay and inaction, it is likely that we will breach 1.5. But I think that upping the goal and, like keeping 2 degrees as our North Star, I just think it's a real political betrayal of the many vulnerable communities who will continue to suffer. So I think shooting for 1.5 and giving it our best shot is just the only real option, with the knowledge that, yes, there are scientific realities that we are putting too many emissions into the atmosphere and we will likely breach. But just to say it's as much sort of a scientific as a political goal.
And of course, the goal in Paris was to pursue efforts to limit warming
Yeah.
to 1.5 degrees. It was already recognized in Paris this was going to be a stretch goal. And the other important thing is if we recognize, as I was one of the coordinating lead authors on the IPCC special report on 1.5 degrees, and one of the things we really emphasized in that report was how much the risks of climate change increase above 1.5 degrees, but also that it's not as if they continue to increase. It's not as if you cross 1.5 degrees and then it's all over. Because that's actually quite a dangerous message to people, is they think, well, we've crossed 1.5 degrees, so we may as well just give up. Absolutely not. Every tenth of a degree of warming matters and has more impact than the last one. And we have a responsibility, if we do breach 1.5 degrees, to ready future generations, recognizing it will be future generations that actually do this, to actually get back there if they so decide if they need to, if they discover that the impacts of climate change are such that they actually need to draw global temperatures back down again. I think this is again one of those delicate things that we need to be aware that this is going to be a likely need in the future, while at the same time not saying, well, chill, we can go to whatever temperature we like because we'll just turn the temperature back, turn the thermostat back down again in the future. It's really important for people to recognize reducing global temperatures is really, really hard. And we actually don't know how possible even that will be for future generations to do it. So let's invest against that possibility. Bear it in mind that we may well need it if, as it looks increasingly likely, we do pass 1.5 degrees, but not use that as an excuse to think, oh well, this is the future generation's problem.
Great. And as well, just to say, which is sort of what you touched on, is that while reducing emissions is extremely difficult, every 0.0001 degree of warming avoided is suffering avoided and
sorry,
worthwhile.
Yeah, but just to stress what I was saying is even more difficult than reducing emissions is reducing global temperature, which is what
right.
so once we've got to net zero in our own emissions, if we discover at that point that actually we've only managed to do it at a temperature where the impacts of climate change are intolerable and we actually have to draw global temperatures back down again, that's even harder than reducing emissions. In fact, arguably much harder than reducing emissions. People tend to rather talk up the difficulty of reducing emissions when it comes down to it, it's actually there's lots of ways of reducing emissions we can do. Anyway, moving on.
Thanks. So this is a question for you, Miles. Really good presentation, Miles. I've missed your lecture. I actually don't know who said this, but that's great to hear. I hear so much criticism, often from fellow environmentalists, that engineered removals are a mitigation deterrent. Where has this come from? And is there actual evidence for this, or is it an assumption?
I think when it becomes clear to people just how hard engineered removals are and how expensive they are, I don't think there is much risk of them being a mitigation deterrent if, and this is a crucial if, you actually couple those removals with generating carbon dioxide in the first place. I think what would be a mitigation deterrent would be telling people, don't worry, you can burn away and the government will clean up after you. That's a very unfortunate message to give people because that really is a mitigation deterrent. And unfortunately, although I fully support the efforts of many governments to build up our engineered removals activity up from its current pitifully low base. At the moment, most governments seem to be approaching this in the way of, well, we'll spend some taxpayers' money on it. And while that's a good way of getting things started, I think we've got to move on quickly from that model of operation for engineered removals so that we make it clear that the reason we're needing to do this is because people are still burning fossil fuels, and make sure that the bill comes home to roost. I'm mixing metaphors there, but to make sure that if you are still using fossil fuels, you're taking some responsibility for getting rid of the CO2 they generate.
Great. Thanks so much, Miles. Another question here is about passive removals. So wonder if you could touch a little bit more about the resilience of our passive removals. I understand that plants, trees, and soil absorbed almost no net CO2 in 2023. If that analysis is, which is K et al., is the beginning of a worrying trend, do our climate models adequately consider this?
That was a scary observation, yes. And it's worth saying it was not predicted that it would collapse that far. There's still groups going over the data and so on. But yes, we are there is a concern that our terrestrial biosphere may be less resilient than we might have hoped. And that therefore this passive uptake may not in future be as strong as we are counting it for it to be in our scenarios. And that would the only thing that would mean is that then in order to stop global warming, we may well have to lower our active emissions. That's the net between what we're still producing from burning fossil fuels and what we're still emitting from burning fossil fuels and what we're actively removing from the atmosphere and committing to permanent storage. We may actually have to move that below zero. We don't know yet. If we look at looking across the models, it seems to be about zero. Some uncertainty, obviously, in what that considerable uncertainty in, but not but. Okay, sorry, I don't want to overstate the uncertainty in this. Whatever this sort of residual emission or removal is required after the date of net zero to keep temperatures stable, it's orders of magnitude less than what we're emitting at the moment. So it's not as if I'm telling you that, oh yeah, well, scientists don't really know what it takes. We do know what it takes to stop global warming, but there is some uncertainty in that, and the response of the biosphere in particular to rising temperatures is a big driver of that uncertainty, and it's something we're having to keep a very close track of through projects, for example, like the Global Carbon Project, which does a really good job of spotting these developments as they occur.
Great, thanks so much. The next question, which I think I'll take, is from Charles Campbell. Is it fair to say that the offsetting industry has confused the net zero issue as it is split between carbon avoidance and carbon sequestration and removal?
I'm glad you say that one.
So I'm happy to say, and then Miles is also one of the authors of the Oxford Offsetting Principles, so I'm sure he has thoughts on this one as well. But I think, yeah, the issue that we see and was just trying to sort of highlight in the presentation is that there's a real conflation of actual removals and offsets, and this phrase that is used over and over, which is high quality credits. And while there is emergent guidance on what high quality means, as it relates to, for example, permanence or additionality, there's not yet this sort of coalescence or, for every credit on the market to actually be high integrity and or crucially, actually providing a degree of removal. So what we see, the kind of explosive article that came out in The Guardian that was, I'm forgetting the name of the journalist who did that.
Oh, you're testing me now. Okay.
Anyways, who basically showed that many carbon credits that were certified as sort of high integrity were sold on the basis of an assumption of deforestation that was actually not the case for the area in which they were being sold. So there was sort of an assumption that buying this carbon credit would preserve it, and the counterfactual is that they would be deforested. But Patrick Greenfield, thank you, George. But that actually the area that they used as the sort of baseline assumption was an area that was being used for creation of roads and things like that. So a lot of times credits are sold on the sort of false premise of mitigation potential and or based on a counterfactual that might not be true. So that's why we're trying to make sure that in the standards we have a real understanding that credits should be used as a contribution to global net zero, but not necessarily used to legitimize further emissions, and that there should be an incentive to invest in long-term, permanent, scalable removals. So any thoughts on that, Miles?
Yeah, I mean, I think it's a difficult situation because many of the activities that are funded by carbon credits are undoubtedly very desirable. And so there's obviously a lot of sensitivity about the possibility of these projects getting closed down if people suddenly sort of lose faith in the carbon credit markets. But I think anyone participating in the carbon credit markets as a buyer, and it's really important to remember that there's always a buyer and a seller in an offset transaction, and the buyer is somebody who's basically wants to continue emitting and using the offsets to claim they've managed to address their emissions. I think buyers just need to be aware that offsetting is going to have to change massively over the next 25 years if we're actually going to deliver our net zero goals. And it will become a much, much more expensive solution than it appears to be at the moment.
Great. Thanks so much, Miles. This is a question about a simple definition of geological net zero.
Sure. Well, it is a very simple concept. It means whatever you take out of the ground, you put back. That's all the complexities in carbon accounting result from ambiguities in trees growing, oceans taking up carbon, releasing carbon, and so on. But what we pull out of the ground, we know. There are no natural processes that result in fossil fuels being produced on any significant scale. So all of the fossil carbon that's being extracted from the Earth's crust is being extracted because of aggressive, often human activity. And the only way carbon dioxide is going to go back into the Earth's crust is if we put it there. Again, the amount at which the Earth's crust absorbs naturally is completely negligible. So that's a really simple balance. And in all scenarios, we do achieve that balance. We achieve geological net zero around the time we actually stop global warming. So it's an essential component of stopping that. It's not the only thing we do. We also get methane emissions under control. We also stop deforestation and all the rest of it. But we absolutely have to achieve geological net zero globally in order to stop global warming. And right now, not a single company or country has actually acknowledged that as a destination. So that's a real challenge for people. Is we know we're going to need to do this. We know it's going to be hard. And so far, it's not yet on anyone's radar.
Great. Thanks for that succinct definition, Miles. The other question is something that has been questioned by different organizations and investors is about the timing of investment in credits. It appears not many frameworks encourage early investment in credits, and many take it that the near-term targets are the priority of what can be achieved through decarbonization, followed by carbon credits later on. This delays investment in carbon credits. Does this need to change, and how can earlier investment in carbon credits get encouraged? So I guess I'd start by saying we'd want early investment in removals and not necessarily in credits at the net zero target date, which is what we're trying to sort of highlight in the presentation. But one of the things that has been emerging is this idea of coalitions or first mover coalitions of businesses that all band together to invest jointly in some sort of removals technology that will pay removals dividends much later than the time that they invest. So coming together and sort of banding resources and putting an investment into a new or disruptive technology with the hopes that once that has its removals potential, that they'll all be able to claim some sort of credit. But in the interim, they're getting credit for the investment that they're making in potentially breakthrough technologies. So that's one of the ways that some businesses are being encouraged to invest in removals at this stage.
And the crucial thing we need to invest in now is permanent carbon dioxide disposal. So, and this is, I guess, is the danger with investing in credits, is if those credits don't result in carbon dioxide being permanently disposed of, then there are potentially a bit of a distraction. But we have to scale up our ability to get rid of CO2 permanently on a multi-billion ton per year scale by mid-century. And that's going to take some solid investment right away. So that people need to acknowledge, if you're still in the business of using fossil fuels, you should be putting your money into permanent carbon dioxide disposal.
Great. So with our final few minutes remaining, I guess any concluding thoughts, Miles? Do you want to start with any?
Well, the main
thoughts?
message, a bit like your opening, I'd like to emphasize to people this is doable. We absolutely could stop fossil fuels from causing global warming by mid-century if we got on with it. And it's important, again, to stress it's not unfeasible economically either. The amount we spend on fossil fuels every year would be more than enough to stop them causing global warming already. So, this can be done, but it'll only be done if governments actually acknowledge the reality of what we need to achieve, which is geological net zero, and put policies in place to require everyone who benefits from our continued use of fossil fuels at the moment. Of course, that's particularly the people who extract fossil fuels and sell them. They need to be required to play their part in a durable solution. So it can be done, but we're going to need some pretty tough decisions made to make it happen.
Great. Thanks so much, Miles. And I guess I'll just say that the sort of frustration or mistrust over the fossil fuel industry from being responsible and holding them accountable is very well founded based on our experience with them so far. And speaking as someone who is extremely skeptic about encouraging removals and what that might mean for mitigation deterrence. I think as time has gone on, I've seen that there is a need to make sure we really strongly guardrail it and make sure that it's done in a way that is safe and acceptable to those who will be impacted. But that we also need to urgently reduce our emissions and think about a cautious use of carbon dioxide removals. So with that, I hope you enjoy the rest of the seminar series. I will see you again in a few weeks' time as we speak about net zero standards again, for those of you who are interested, and really looking forward to chatting with you soon. And to sign up for those webinars, you can visit the website and there's a link in the chat to look at those future webinars. Great. Thanks so much. Enjoy the rest of your day.
Thank you very much.